killed a lot of my time, so I couldn't finish the lab. But hopefully, during the session we will try to finish it up. And yeah, let's say our idea today is that we will have an. I understand that not most of you are not from the machine learning background, so first I would try to give you an overview about what is machine learning, and then I will also talk about what exactly is MLOps. So let's say, many of you know DevOps. What is DevOps? So you can say MLOps is nothing but whatever DevOps does to software engineering. You can say MLOps does to the AI ML model development. That's exactly that's probably the simplest term of definition to give to MLOps, but yeah, software engineering and machine learning has lots of differences. That is where a lot of challenges would also come when you are operating a machine learning model. So that is why many times MLOps has slightly more complexity when compared to DevOps, because you have to deal with a lot of hyperparameters, you have to deal with a lot of data that was used for model training and everything, which was not a big challenge when it came to DevOps. Software engineering was much simple, but when it comes to machine learning, there are few extra layers of complexities that add up, and that would be the responsibility of the MLOps engineer to handle those responsibilities as well, which we will get into. But yeah, that's the simple definition for machine learning, and then we talk about the importance of MLOps, and then we talk about some key concepts and stuff, right? And then building. I won't be using this presentation a lot, but I just wanted to give you a clear understanding about an overview what exactly we are planning to cover. Then we will get into building an end-to-end MLOps pipeline. So before that, I have to demonstrate how exactly a machine learning model work. How do you train a model, and how do you test a model? And after that, after that, we will get into MLOps and how do you create some automated CI/CD pipelines for machine learning. And then, yeah, I wanted to show you a live demonstration with commands, which those who are interested can actually try out yourself. So it's now in 2 hours, we are not going to cover a lot of things, right? Practicals and theory both is what I am trying to complete. So this is just wanted to give you a quick demonstration about what we are planning. So I will start with the most obvious topic. What is machine learning, right? So these are some topics we will come into. But before we go there, let's talk about what is machine learning, right? That's an important topic we should talk about first before. So all of you are working in IT companies, so you will have a fair understanding about what is software engineering. So I'm not getting into that, but those who are working in software engineering, you have a clear idea. There are different teams working on software. There are developers, QA, security teams, network engineers, operating engineers, the people who do the testing, and right, there are a bunch of people who are typically part of a software engineering team. And when it comes to the machine learning, the complexities only increases because, right, machine learning model needs to be developed, right? And for that, you need to do the coding. Typically, Python is one of the most in software engineering. You deal with a lot of programming languages. When it comes to machine learning, as of today, Python is one of the most popular programming language when it comes to machine learning because of its lot of availability of many libraries that helps the developers develop a fine-tuned AI ML models, right? And that's because of that, most of the companies who build machine learning model, Python is one of the most important programming language. But when you work as an MLOps engineer, you might not be responsible for developing models. For that, there would be a separate team, just like you have a software engineering team has developers. Here when you are trying to develop an AI ML model within a company, there would be a team of developer who would be uh, creating the models, writing the code that creates the model, and using different Python libraries and some open source models or custom created models. And they would be taking some data set and training those models and producing the final executables, which you can deploy to a server and make this model, serve this model to the people who wants to use it, right? So basically, for every machine learning model, I mean, one common thing what you would find is that, a set of, yeah. Any questions? No. Yeah. Okay. So one thing that we typically do when training a model. So training a model, what typically means, you have a, typically it could be a library or it could be a custom developed model within a company, which is trained with some data sets. So let's say we have some data sets. You can take any example, such as, let's say you have a vegetable. I mean, think about carrots, right? You have the measurement of 1,000 carrots, and then you want to categorize those carrots into good, average, or below average category. So basically, you can what you can do is you can provide the data sets. Let's assume you have the measurements of 1,000 carats, right? How its length, its width, and also the diameter at both sides and also in the middle. Let's assume you have measurement of carrots, right? The vegetable carrots, and you are feeding that data to a model, and then you produce some sample outputs. For example, if a carrot has to fall into a good category, it should have these many. I mean, basically, you just tell within the data set, you provide the informations which carrots falls into good category, which carrots falls into the average category, and which ones falls into, let's say, the bad category, right? Let's assume that's what this model does. It can categorize things, right? For example, right now we are trying to categorize carrots, and we provide the measurement of the carrots, and we also tell the model which category these carrots belongs to. And what this model has to now study is, what is the relationship between the measurement, I mean, which we typically call the feature, right? So there are different features such as length of the carrot, width of the carrot, and diameter on three sides, right? Both edges and also at the center. And that information, once it is provided to the model will try to identify the proper relation between the feature, which is nothing but length, width, etc., and also the category that they fall under. And you can actually say it would produce some equations, right? It would produce the relationship. You can say some mathematical equations it would actually produce. And this package what the model has produced, or probably you can call it some mathematical equation that have been produced by the model, can now take a new data set, right? You can actually provide a different data set. You can just provide the measurement of another carrot which you haven't categorized, right? You just provide the measurement of another carrot, and this package can predict whether that new one falls under the good category, average category, or the bad category. So that's exactly what the training of a machine learning model will look like from a technical perspective. So where do we, and these models could be a third party library that you use in your company, or it could be a custom model that is developed in a programming language like Python within your company, or Python has many libraries and many algorithms and based libraries available. Most companies takes one of those libraries and then train those models using the data set the company has, and they produce different packages that understand the relationship between the feature, which is nothing but the input measurements, and then the output, which is nothing but in this particular case the categorization. So categorization is one of the example, one of the many things that a machine learning or artificial intelligence model can do. There are different types, ways an AI model can work. I mean, if you think about ChatGPT, it's a much complicated model. It can do a lot of things, right? It's not just about categorizing things. You know, you ask ChatGPT anything you want mathematical calculations, or you want categorizations of things, or you want prediction of things. I mean, there are a lot of things that ChatGPT can do. So typically, a model looks much more complicated than this in real time. But this is just a basic example on how exactly a model function, an artificial intelligence or machine learning model. This is how they actually function. And now, what are the challenges, right? I mean, while you need operation, so there would be companies who want to develop a ML models at scale. And today, the situation is completely like so. 2 years before, this was not the situation. There was ChatGPT, and there was only ChatGPT, and the ability for every companies to build their own AI models were very much limited, right? And today the story has changed. Today there are many AI models being developed by different companies, and developing an AI model is no longer a difficult thing. And most of the companies, even most of the IT companies, are actually developing their internal AI platforms all by themselves. Internal AI platform, what that means is a company can develop an AI platform, and that can be used by its own employees or the people who are related to that particular company, instead of using ChatGPT or things like that. That is bringing in a lot of complications when it comes to legal compliances and many other things. So most of the company want to use AI, and they do not want to right. So it's important that companies uses AI. So it's not due to the compliance and stuff. Many companies don't allow third party AIs to be used, and many companies, because of that, they're developing their own internal AI platforms and everything. So this is going to be a huge rush that is we are going to witness in the next few months and few years. A lot of models are going to get developed within many companies, and a lot of new open source models are also going to come as soon as the development, right? As soon as the competition begins. If you think about software industry, that's what happened before. When in the software industry, we are expecting the same story here. So when things grow, that is when things get complicated. So if a company wants to develop a ML model, that's great. Nowadays, developing an AI ML model is not such a big challenge. People can do it if they invest enough amount and invest enough time and enough resources. They can actually build an AI ML model. But the question is, how quickly can they build, develop, and deliver those models to the usage, right? That's very important. And it was a very complicated problem in the software engineering, and that was the reason why DevOps evolved eventually. When it comes to the machine learning, this is a much more severe problem because of the complicated structure that machine learning has. Because think about it, and when it comes to machine learning, you have to worry about the data that you use for the model. You need to worry about the model. You also need to worry about the feature, and then the relationship between the feature and then also the output variables. And also there would be a lot of parameter that you should also handle, right? There can be, one to hundreds of parameters that an AI ML uses while during the training, right? Things like ChatGPT uses trillions of hyperparameter. So most of the AI model, you would have to deal with too many hyperparameters that would be used for the training, and those hyperparameters needs to be tracked as well. So it's not just the code, guys. So it's code, parameters, data sets, and everything. So you have to manage all these things together, and a lot of legal and compliances issues would be something that you would be dealing with when you work as an MLOps engineer. So when we compare machine learning with software industry, there are a much more complicated problem that is going to arise within the companies, and that is where MLOps is going to become very, very strong and important aspect for every company. And now even the people who, right, people who start their MLOps journey today, they just like, I mean, if you think about DevOps 10 years back, whoever started with DevOps 10 years back, no, they grew a lot in their 10 years, right? So basically, I mean, when you become an early starter in an industry where the industry demands the most of the people, that is when we make the best out of it, right? So MLOps has that advantage. It is kind of, at this moment, there are not many people who know MLOps, but even at this moment, there is not a very huge requirement for MLOps. There are lots of requirements that keep coming in, but it's not that much huge. But it's going to grow exponentially in the coming years, and there is going to be a huge lack of eligible people who would be able to fill out those requirements. So that's one of the reasons MLOps is considered to be one of the most important career today. I mean, if you consider the next 10, 15 years, right, MLOps is one of the best and right choice today. All right, so enough of that, and what I'm not talking too much about machine learning today. I hope you got a basic and clear understanding. I'll directly get into a quick live demonstrations. So I already have a model which is written in a Python programming language, which uses an external Python library as a model, and I provide you some data to train that model, and then once it is trained, I keep things simple. What my model does is, if I provide it the square feet of the house, it would, and I would also tell it what is the price of that house, right? So it is a easy equation the model can figure out. So for example, if the house is 1,000 square feet, the price would be, let's say, 1 crore. If the house is 2,000 square feet, the price would be 2 crore. So I provide a data set that consists of both the price and the square feet, and then the model get trained with that information, and its model would then figure out the equation between the square feet and the final price. Of course, it is a very simple equation, but for keeping things simple, this is the example I have written. And now, once the model is trained, you can actually provide a different square feet. For example, 950 square feet. The model should be able to predict the price of that particular house. So that is exactly what I'm trying to develop here. So let's get started with that. So before we get into this, anyone has any questions, can ask me. Any doubts, questions? All right. So let's get into a practical. So my idea is that let me move I'll be sharing this document with you through email or something. All right. So let's talk about a sample model. Machine learning model to predict the price, which we call output variable. That's a technical word which is used in machine learning, from square feet, which we typically call, it's a feature. Basically, we provide a feature, and from the feature, it can predict, it's not one feature, it's many features that you can provide, and it would typically predict output variables, one or many. So in our particular case, we kept things much simple. So we have a model which is nothing but a Python program. And like I said, Python supports a lot of machine learning libraries. And for a Python developer, he can pick from a lot of models available within those open source libraries, and they can use them for their training and producing those predictions and artifacts and stuff, right? So I have a model and I also have a data that I want to use for training. And in the data, I would be providing both the square feet and also the price. And I would be feeding this data. Maybe I have like 5 houses information or some 15 houses information I have. I would provide this information to the model and I would ask the model to learn the relationship between the feature, which is nothing but the square feet, and the output variable, which is nothing but the price. So model will check the data, read the data, and find some predictions, figure out what is the relationship between the square feet and the price, and then it would produce some kind of executables, or you can say executable equations, which is nothing but software code, right? Which if you provided with some new data, some new square feet information, now it can actually predict the price, right? It will tell you the price. So, and then again, there is a matter of accuracy and testing and everything. So typically what you can do is, if you have the data of 20 houses, you can tell the model that, you take the 16 houses data for your own training, then you produce an executable file, and then the remaining 4 houses data, you just try to predict it and check if you are getting the price correct or not. I mean, this way you can also do some kind of evaluation, which is very, very important. After you trained a model, you have to evaluate the model by using some different set of data. So if you have total 20 houses data, use the 16 houses data for the training, and then probably the remaining 4 houses data for validating that the produced model or the trained model is actually making the right prediction. So this is what we are trying to do today. So I have a Python program which I kept in GitHub. So you will have access to all the code what I am sharing. I would also be sharing this GitHub link with you, but today you don't have the ability to do along with me because of the time constraints what we have. So if you go to this GitHub, if you go to the app folder, you can find a program called simple ML MLflow csv.py. So what I have is a CSV file, that is my data file. So that is where I have the data, and this particular Python program is my model, that where I use some libraries, right? Something called sklearn linear model, and that is nothing but a model that is available through this particular library. Right. I'm going to use that for my training and as well as for prediction and checking the accuracy of those predictions and everything. So I will quickly summarize what I am doing here so you can actually see. I have the data which I kept currently in a CSV file, and that CSV file is inside the data folder. So I have a folder called data. Now you would be wondering why would someone keep data files in GitHub? It's a bad idea, right? We will come to that later. For now, I kept a sample CSV file in the GitHub just to demonstrate. I have 5 houses information. There are a 500 square feet house would cost 25 lakhs. 1000 square feet house will cost 50 lakhs. So like that, I have 5 houses and their square feet and also the price, and I would be feeding this data to a model, which is nothing but my Python program, which I kept in a different folder. I'm going to take you to that program. So this, sorry. Um, in the app folder. This is the Python program. What this Python program does is it takes this CSV file and it will take the data from that CSV file, and then it would be using some model which was available on the web to train your model, and also to do some prediction and evaluations and stuff. So I'll just quickly walk through it. So basically, this is your feature and this is your target, a target variable, the output variable, what I meant to say. And we have some, yeah, so we just split the data into two parts. One data would be used for, like I said, out of this 5 records, I want to use 4 of them for training and 1 of them for testing, right? So I split the data, and there is total 5 houses data. So I split that into 4 and 1. And then I take the first 4, which I call X, and then the Y are nothing but the one which I want the other house. Okay. So what I do next is I train the model. Just a second. Yeah, I train the model. This is the particular command, particular line of code that I use for training the model. And similarly, this is the command I'm using for making the predictions. So I split the data into 2 parts, and I use the first 4 house data for training the model, and the last 1 house data for making the prediction of the model, to make sure that everything is correct. And then I am also recording a lot of information, and even I am also plotting that information somewhere for somebody who wants to try it themselves can execute this program. And then they can also record a lot of information, such as which model was used for the training, and also different hyperparameters that were used. One of the hyperparameter that we used in this particular case is what is the size of the test data. So 0.2 means 20% of the data. So total 5 houses, 20% of 5 houses would actually mean 1 house, which we use for training. So we can identify. Okay, let me put it in this way. So hyperparameters would provide some configurations to the model when you are training it. So what that means is, when you are training a model, you have a decision to make. One of that decision would be how many percent of the data to be used for training, what percent of the data to be used for testing, which could be an important variable, because, yeah, go ahead. Sandeep, you are speaking something. All right, sorry. Yeah, what I mean to say is, no, that if you change that percentage, I mean, tomorrow you decided to make the ratio 60% and 40%, maybe the model performance would actually change along with that. So if you change these parameters, there's a good chance that the performance of the model could get affected. Maybe the performance will improve or it could decay. That we have to find out by continuous testing. But something will happen if you change that percentage ratio. So such parameter that we use during the model training, we call them hyperparameters. And in this particular case, test size equal to 0.2, which means 20% of the data to be used for testing. It is a hyperparameter. If we later modify it, this could potentially impact the performance of the model. So such parameters are always used when you train a model, and those tracking those parameters would actually become very, very important when you develop a machine learning model, because tomorrow you would be retraining this same model again with different set of data. And during that time, maybe the parameter can also, you can decrease or increase, and figure out if how that is getting affected during that model training, if the performance is improving or decaying. I mean, we can figure those things out. So hyperparameters are important, and every time a model get trained, we would be using different values for those parameters. So every time you train a model, it is important that you should be tracking those parameters. So when you think about software, let's forget about machine learning. If you think about software, the only thing you ever need to track is your code, and you have Git, you make a commit, it got tracked, right? There is nothing else you need to worry about. When it comes to machine learning, you should you can still use Git, but it's not just the code. It's the code, and it's also the parameters, these hyper parameters, and also these data sets, right? All these things needs to be tracked. So every time a model get trained, a particular snapshot of the data was used, particular snapshot of the hyperparameters were used, and a particular code was used. And you should be tracking all the three for the later future purpose, right? You are producing a model and your customers are using it and they are experiencing a problem. And how do you do the reverse engineering? You want to know which code was used for producing that particular trained model. You want to know which data was used for training, which parameters were used, and what were those values. There has to be a proper tracking in place when it comes to machine learning. That's why I said machine learning could be a little bit more complicated than software engineering. So yeah, anyway, I mean, the point what I try to make, you don't have to understand this Python program. You just need to understand a few things. This model, what it does is it uses for houses data to train the model and produce the necessary equations or executable files that can make future predictions from an unknown data. You provide an unknown data to it, and it will provide, in this particular case, the square feet to it. It can produce the price of it. So basically, that's exactly what it is. So I'm going to execute run this particular model, and let's see how it works. I'm going to run it on my laptop. It's a simple algorithm which doesn't need a lot of CPU memory resources. You can actually try to do it yourself in your laptops also. What you have to do is I have provided the instructions to execute this program by this is the documentation. You can just execute these commands one after other. You also have to install one more library. Yeah, let me do that. I'm going to get this code to my laptop. Make sure that Python is installed on your laptop. I go to some /temp folder within my laptop. And I'm going to run these commands from there. I'm going to simply execute that Python program in my laptop, which essentially train the model and produce an executable trained model. So I'm going to run these commands, and I'm also going to install one more Python library that is required. It's called MLflow. That's the Python library, which actually I had mentioned here in the documentation before you could execute your program. So I'm going to do that as well. So a bunch of Python libraries to be installed, Python modules to be installed before you could execute this Python program. So these are those. Maybe I can add make the change here. So you can, if you want to try yourself, we can do that. Yeah. And once all the modules are installed, the next thing that I would want to do is I want to execute this Python program, or in other words, I just want to train the model with the CSV file what I had provided. So I'm waiting for all the Python modules to become ready. Then I can execute the program. And typically, like I said, an MLOps engineer don't bother too much about the programming. So whatever Python program that you see right here, typically it is created and managed by the development team. So you don't need to be a coding expert to work as an MLOps engineer. But still, if you have some knowledge on Python, that would be helpful. try to understand a few Python libraries would also be helpful. Not the Python libraries that developer uses, but rather the Python libraries that are used for tracking, monitoring, and stuff. There are few Python libraries that does those things, right? Anyway, so let's talk about let's see what is the progress. So modules are installed. Now I can run the Python program. So basically, I am executing, or you can say I'm training the model, and the model get trained. Model also produce the prediction, and it also evaluate itself by using that 20% of the data that you provided, right? One house square feet, and also the price. It will take the square feet, make the prediction, figure out the price itself, and compare the price with in the data file, CSV file what you provided, and it will measure its own accuracy. I mean, all these things it will do itself, and it will also create some plots, some diagrams, and some PNG files that I can see to see the accuracy of the model. So let's go ahead and take a look. What I'm going to do is I'm going to execute this Python program, which is in the app folder. This is the particular Python program that I want to execute. The command is python3 space app slash the name of the Python program. And this program is now being executed. It is taking the data, whatever is put inside the data folder, that CSV file, and it is using that data to train the model, and it is now also evaluating itself, and it would also create some executable artifacts, which I will show you where it get created. Now the program is running, model is being trained, and we wait we wait. All right. It may take some time when you run it for the first time. So let's wait and for a few more seconds. Okay, and no such file or directory. It says there is no such file called, which is strange because there is a file, ls data. Oh, I'm sorry. Actually, the file name here, it's datas, so which I'm going to change, not in the GitHub locally, because GitHub we will find a better way to manage it. Right now, I just cloned the code, but the data file has a wrong name. I'm going to rename it. Within the data folder, you have this file, and it should be, the file name was wrong. I changed, put S at the end, datas. So now let me rerun the Python program. This time it should take the data file, and yeah, now it's creating some experiments. It's doing the training basically, and it is now producing some experiment, or you can say an executable equation. And I also have some program which I have written at the end to create some diagram based on the prediction what it had made. So this red color is the prediction. This blue color is the actual data. You can actually see they both are in the same line. So there is no error, zero error, because red is the prediction and blue is the actual data what we provided, the five house information. And the price you can see in the y-axis, and square feet you can see in the x-axis. And this is mathematically simple equation, and it predicted it very correctly. So I'm going to close this, and now that's it. The Python program is completed, and a Python program did not simply complete, it actually produced that artifacts, which if you want to find out, just type the ls command. You would see a newly created folder called ML runs. If you get into that folder, you would find another random number. It could be, if you are using Windows, it could be a much bigger number that you will see. If you are using a Mac, most probably it would be a number that you see. Get into that, whichever that is, don't worry about the name. Just get into that folder, type ls, and you can actually find the experiment that have been created. And if you get into that particular folder, every time you execute the program, you would find a new folder here, actually. So if I rerun the same program one more time, then it would result in another executable files and all the metadata information. So I get into that folder which got created, and then I type ls. You can actually see an artifact folder. If you get into that artifacts folder, you would actually be able to find, this is the name what we had given to the train model, and there you can find a package file which is an executable artifact. You can run it on it. You can copy to a server. You can run it on a server. You can serve it on a server if you like. But we will do all that later. But yeah, this is an executable package that you can run in a developer laptop, or it could be in the cloud, and it can make the prediction. It's nothing but your trained model. You can run it on any machine in the world, then it would start running, and then you can give the data input, which is nothing but the square feet. It can produce the output. This is your package file. Along with the package, a lot of metadata information also get produced, what Python libraries are required for this, and the kind of Python environment you need to run this particular artifact, and a lot of packages that you might need on the server where you are running this package, and many other metadata information also get produced every time you execute the Python program. And let's see, this is the folder structure that got created. If I type ls tree, what was the command? ls. How do you see the files in a tree format in your laptop? Any idea? There
Tree,
was
right?
simply tree, right? Yeah, yeah, tree. So just run the tree command. Now you can actually see the data in the tree format. So ML runs every time you execute your Python program. And technically, what happens is, within the folder one, a new folder get created. So in our case, we executed only one. So that's why there's only one folder within the one folder. And then there you would find an artifact folder, some meta.yaml, metrics, parameters. Parameters are nothing but random state and test size, which you would be wondering somehow they got recorded. Did you see we recording these? Actually, we were recording these in our Python program. There were few things that are important to be tracked. One of them is nothing but these hyperparameters. Then another one is the square feet, the feature. Then other ones is the price, the target, right? And then also which model was used for the training. In our particular case, a particular model was used for the training, and we want to track that models also. So who were tracking all this stuff, right? It is well structured, right? It has your executable file, and along with all the metadata information, it has the metrics, it has the parameters, and it has the tags which are randomly created, automatically generated. But anyway, got some tags that would uniquely identify this particular artifact that have been produced. So who tracked all this in such a well manner? That was the job of another Python library that we used. It's MLflow, a very, very important Python library, very relevant not only to the developer but also the MLOps engineers, right? We were using something called MLflow there. We used some command called set experiment to start the tracking of the stuff, right? And we were logging these parameters, the test size and random state, which is nothing but the hyperparameter what we used for training the model. So those things we tracked in MLflow. These are the code that we use for that, and then the metric and also the model. So these many tracking we already did, right, along with the Python program. So, and if you noticed, there are few more programs at the end of it where I have used some plotting, right? For plotting, it uses some other libraries. Here, the matplot library was used for that, and we used that particular library to create some plots, which you have seen in a graph, XY shaped graph, which was a straight line. So this is, this is the work of the MLflow. I mean, yeah, this is not the tracking. I mean, plotting is optional, but tracking is very, very important. I mean, right? Like I said, training the model is a continuous process. Every time a model get trained, you have to, let's assume the data got changed. I'm going to actually, literally, I'm going to change some data. Let's say I go to the data folder and I'm going to change the data. I'm going to modify that CSV file. Maybe I'm going to insert some more data, let's say 3000 for 3000 square feet. What is the price? So I'm going to write down 150 and I'm going to save this. So assume the data got changed. Actually, the data what I have added just now will not make much relevant changes because it's basically square feet and price, a prediction even humans can make, not only the machine learning models, but yeah, I'm just keeping things simple for now. So let's assume there is some change in the data and assume there is some change in the hyperparameter also. I'm going to make some modifications in the program. Maybe in the app folder, I go into and then I make the modification of one of these hyperparameter. Let's say instead of making it a 20%, I'm going to make it 40%. So which means out of 5 houses, now I have six. So out of 6 houses, 40% of the data would be kept for testing. The remaining data would be used for training. So basically, this hyperparameter changes can actually affect the performance of the model once it got trained. So let's assume you are changing something, you must track it, right? So when I run the program for the next time, probably the behavior of the model will change. So you have to produce a whole new artifact, right? So this time it is actually producing a whole new artifact. Actually, the behavior, the accuracy, there is not change in the performance, but let's assume in real time, whenever there's a change in these parameters, the how the model perform would also actually change. So now if I try to run the tree command, you would actually see this was our first artifact, and now there is one more artifact. I mean, which was our first artifact? The one start with 9.2. This was our first artifact. And you can actually see along with that, there is one more folder got created within the folder one, that is our new artifacts and stuff and the related metadata. So MLflow is every time you execute the Python program, you can actually see MLflow is tracking all these stuffs and then creating all the information, the artifacts, parameters, and lots of tags it produce, and it store them in a separate folder. Every time you run the command, a new folder get created, basically a new artifact get created, which you can take and even run it on a different machine if you like. So basically, this is how a machine MLflow and works, and this is how developers can use a library called MLflow to track the stuff. And typically, they want to track the model, the metrics, generate tags, and also track the hyperparameters and everything. So these are the things typically a developer would want to track every time the model is being trained. And MLflow is an awesome library that will help them do that, right? And as an MLOps engineer, for you also, it's MLflow is very, very important library because it does the tracking purpose. It's important that we keep one of the primary responsibility of the MLOps engineer is to keep everything in order and do the troubleshooting, how an understanding about how the tracking works within the artifact production process, right? So that's one of the responsibility that we hold to. Hey Bola, you are on mute. You have any questions?
Oh, sorry. My bad.
Now, all right, guys. And now I think we are done with the basics of machine learning part, and let us get into the MLOps workflow, right? That's why we are here. But it is very difficult to proceed to the MLOps without having a basic understanding about how do you, not only how do you train the model, how do you track a model using Python libraries such as MLflow. All right. So and that's why I would mention it a workflow here. So you need a data set. It could be the square feet price and square feet and the price. And then there must be a model that you want to train, and then you want to produce a bunch of artifacts and track different set of things for each of those artifacts. And then preferably you might want to build these artifacts into a container. You can run these artifacts on a computer, actually any machine that has Python installed. You need to install some extra libraries and stuff, and then you can execute these artifacts in those machines, right? It could be a developer laptop, or it could be any machine in the cloud. You can run it. You can use MLflow libraries provide the ability to execute these artifacts as well. So if you have MLflow installed, you can run these artifacts all by yourself. And any machine that has MLflow installed can execute these artifacts. We will get into that, but I'm not directly executing this artifact. My actual plan is to build a container image, right? That's what we always prefer to do. We can run the models on a laptop just using a command line, a MLflow command line. MLflow also come with a command line which you can use for not only for training the model but also for running the model. But we are used to run things in containers, right? That it's they are more convenient. Like especially if you want to run your models in Kubernetes and stuff, you have to make your containers, right? So that's what we are going to do next. We want to make a container and put our artifacts and everything the artifact needs to run together within a container image, and then you probably want to run that container, probably, right? Try to run the container. You can use Docker or things like that. And then probably you want to, if everything looks good, you might want to push your container image to a registry, something like hub.docker.com, or it could be a cloud registry. You want to make sure that your models are now uploaded to a registry, then probably you want to do some continuous monitoring. That is something that we are not getting into today due to lack of enough time, I can say. All right, so we will start with the first step, get as a single source of truth, right? So here, since it is machine learning, I am worried about two things, not just the code, but also the data. And it is not very practical to put data in Git, right? So I mean, it's not very practical if the data grow in size, right? If there are megabytes or gigabytes of data that you're using for training your model, you don't want those entire data to be put on Git, but still you want Git as the single source of truth. So how can you make Git as single source of truth without maintaining the data? So that is where you need some additional tool. That tool can produce data snapshots. So every time a model is trained, it will take that particular data and take the snapshot of that particular data. And that snapshot is big. It has the entire data. And that snapshot you store in a cloud bucket like S3 bucket or some object store or Google Drive, or basically a storage that is meant for storing the data. And then you would take the metadata of that particular snapshot, and which is a simple, it could be a hash value or something. You take that value and store that value in Git. So basically, Git now still has the source of information. Let's assume you have Git. right? Let's assume you have Git and you have your developer continuously storing their code in the Git, right? It could be the model by the programs or whatever program what you have seen are being stored in the Git. The problem is that every time they make change to the code or not, basically you can say every time a model is being trained, the respective code should be kept in the Git as a new commit, right? Which is great. But how about the data? And in order to manage the data, let's assume you have some storage, a cloud storage. It could be AWS S3 or something that can actually handle the load of data. So what you would do is your data, you would put together, I mean, in our case, it's just 5 houses data, but in real time, it can be huge. So whatever that is, you take the snapshot of that particular data that was used for your model training, and the developer would create a snapshot of the data in the cloud storage. And then what they will also do is they will take a signature of it, maybe a hash value, which is like, few bytes in size, and that hash value you store in the Git for the tracking purpose of the data, right? So what does that mean? Let's assume somebody who look into the GitHub, they not only get the code, but also get which snapshot of the data was used for training this particular model, or for this particular commit, what is the corresponding data that was in use. So anyone can take the code, take a particular commit from Git. They understand this commit has this particular version of the code and this particular snapshot of the data. And then they can download this data. Once they understood which snapshot of the data to download, they can get that data downloaded to the machine, and then they can reproduce, right? That's the whole purpose. You should have the ability to reproduce the code and data anytime you want that was used for training, or whatever developer used the same data. And maybe assume you have a Jenkins server or something that you are using for building the models after developer did some local testing in their laptop. Let's assume the developer used this data to do some local testing on their laptop. He felt good and he committed it. And now let's assume you have a Jenkins server, which is taking considering Git as the single source of truth. So it takes the codes from that particular commit. So it takes the particular commit from Git, and it got the code from Git. Then it understood which snapshot was used, right, from that hash value that was stored in Git. Now Jenkins understood which data was used. Jenkins has that information, and then Jenkins downloads that data. And then probably let's assume Jenkins is the one who is training the model. Jenkins executes, or Jenkins runs your Python program, or Jenkins can now train your model. So this way, it should be reproducible, or Git should be the single source of truth if you want to do things right. Okay. So this is the way how it should be architectured. And yeah, like I said, we already tried these commands and executed the program. So now let's go to the next step. Now the next thing is that the ability to access the data set, right? So let's assume you are going to use a Jenkins server. Do you have any questions? Am I going too fast or too slow? Are you able to follow me? Any feedback? I'm sorry, I'm going a bit fast so that we can cover things within time, but I'm also trying to simplify the stuff as much as I can. I hope. Yeah, I hope you're following. Anyone has any suggestion, comments that you want to share?
No, it's okay.
Yeah, cool. Feel free to not drop me a message, in case if you would like to, right? Great. So yeah, so then I'll go ahead. So the next thing that you might want to do is, let's assume you want to use Jenkins. So Jenkins now have the ability to access Git. Let's say you told Jenkins where your stuff is, where is your model, and where the model tracking, I mean the data tracking and everything. You told Jenkins where they are, and now Jenkins take the code from Git. Jenkins identified which data was you need to be used for training, and Jenkins need that snapshot. It need to download that particular data snapshot, and typically that data snapshot, the original data, would be kept in a remote storage. So basically, Jenkins now have, let's assume this is a bucket, Google bucket. That's where assume your data is stored. So basically, Jenkins need to have the ability to download the data from that particular bucket once Jenkins identified from GitHub which data it need to download. So for that, you need to use some, actually there is for this, for managing the data snapshots and metadata of the data, in addition to Git, we are using one additional tool, which is actually very much similar to Git, but it's for data, right? Git is for code revisioning. DVC is for data revisioning. You can create data snapshots over time using DVC, just like you create code snapshots over time using Git. So that's what DVC is. It's a short term of data version control. It's a tool that is open source. Anyone in the world can use for creating revisions of the data. So let's assume I'm not getting too much into DVC, but you can just go to the DVC website, follow their getting started guide. It's pretty simple, pretty straightforward. Just try to install it on your laptop. Just take any data file, any CSV file or something, then you try to revision that data file. I mean, you will understand how simple it is. But today I'm not getting into so much stuff. I already have the commits in Git, right? In this Git repository, I actually already have commits. There are actually 24 commits so far. Anyway, it's not the important part, but what is the important part is within the data folder, I am tracking. This is not a file I'm supposed to store in GitHub. I know that. And actually, I'm not storing it. It's just a file lines, but my actual data could be huge size, and it's not in Git. The actual CSV file I want to use is actually not in Git. This is just a sample file I kept in Git for your reference. The actual file is this, which is not a original CSV file. If you look at this file, it would be just bytes of size, not even kilobytes. Go ahead and open this file and take a look. It just tells me the hash value of the file to be used, and also the name of the original file and the size of the original file, basically. So obviously, this is the only file you store in Git, not your original CSV file. Where your original CSV file is stored, in my particular case, it's actually stored in a Google Cloud bucket, right? So it would be the responsibility of the Jenkins to download that from Google Cloud bucket. But I need to be worried too much technically? No, I already have something called DVC that has the ability to manage these kind of complications when it comes to data. I tell DVC that where exactly my storage is. So this is a Google Cloud bucket, actually, URL of a Google Cloud bucket. So I just tell DVCs that this is where the actual data would be located. And then I tell DVC that DVC can use these particular credentials. I already created these credentials in my Google Cloud. And then this command will tell DVC that DVC wants to download from this Google Cloud bucket. This is the credential to use, right? It's as simple as that. Then DVC has some caching issues, which is why I'm clearing its cache before I do my next job. So basically, I'm not downloading the data yet, which will be the next command, DVC pull. So before you could actually download the data, you need to set up the necessary authentications. You need to tell Jenkins or whoever is downloading the data, you need to tell them where the data is and how to authenticate with that particular storage. I provided that information, and then the next step would be basically to get the data set from the remote store. So DVC pull is a command you can simply run automatically. It will, the pre-configured Google Cloud bucket. It will connect to that Google Cloud bucket, download all the data to your Jenkins server now, right? So that's the thing. So now that's what you do. You download the data snapshot in the next step. And once that particular part is completed, it's time to train your model, track your data, and you already have MLflow, right? You already have MLflow doing all that job for you. We just try to execute this Python program all by ourselves, and it produced the executable file, that folder structure that we have seen. So we want to do that next, right? We want to train our model and produce the trained models or artifacts, which are, you can consider them to be like software executables that you can run on a computer, and then you give the square feet to it and it will give you the price when it is running, right? So that's exactly what we are going to do next. We want to produce those artifacts. We want to train the model, track all the stuff like parameterize model and stuff, and also produce artifact, and everything can be done just by executing a Python program. So that's what we are going to do next. We are going to train our model and produce the artifact.
So basically one
So
question, this DVC will support all the cloud storage, or?
DVC supports a multiple storage. Yeah, it supports AWS, then Google Cloud, Azure files, and a few things. So they have a list of things published on their website. Yeah, these
Okay,
major three cloud providers they support.
sure.
And Dropbox
Thank you.
also. All right. So the next thing we are going to do the stuff, right? So a few things like train model, also evaluate the model, like using that 40% of the data, it will evaluate the model, and use 60% of the data for training the model, and then track everything, right? You have seen how MLflow is tracking the stuff. Then you should also want to create artifact, right? So all these things you want to do, and all you have to do is just execute your program, and all the stuff are done. So this is the next step, right? If you are building a pipeline, this would be the next step that you want to do. And then I also said, right, not the artifact. Especially we DevOps engineers, we need containers to do everything. We want to put things in the container so that everything would be easier to manage. So that would be our next step. So let's say we want to build the Docker image. We want whatever artifacts that was produced, along with every dependencies those artifacts need. Actually, those artifacts need a lot of dependencies. They need Python, they need all those Python libraries, they need a number of packages on the operating system, and they need artifacts, and you want to execute that artifact using the MLflow library. So it need MLflow library. So there are a lot of things that you need in order to execute your machine learning model. So if you manage those things manually, I mean, how things are, right? Especially when we come from a server background, right? So you don't want to manually manage those stuff. You want to put all the stuff in a single container and use that. So that's the next thing. So for that, we are actually going to build a container image, and building a container image is actually a single step process. We still use the same MLflow command line to do that. The command is MLflow model, build Docker, and then you just mention run ID. Run ID is nothing but every time the machine learning model run, it produce a unique ID. That's called run ID, right? So we would use this as the unique identifier of each artifact, right? Every time we run the program, it produce a new run ID, experiment ID. So we use that run ID, and then we call that image, you tag that image with the same run ID. So every time you create a Docker image, you tag it. Better, instead of simply using latest or something, you use a unique name for each container image that you produce. So I'm using the same run ID, which, right, that random string that got generated when you executed the program. I use that as my Docker container image tag as well. So this command would actually produce, it's not a Docker build command that we are using, we are actually using the MLflow models. This will simplify a lot of stuff. That's why we are using it. So this would produce, okay, I think I was setting up a Jenkins parallelly, and now I see, oh, okay, actually it worked. Yeah, it's awesome. Even though I got some other failures, which is okay. Yeah. Yeah, great. So this is the next command we have to use in order to build the container image. And once you build the container image, now it's time to run our model as a container. So that would be our next step, which I didn't write down. So run our application as a container, as a Docker container. So on any machine that has Docker installed, you can run a Docker container. So we already produced the container image in the next previous step. So it's time to create a container now using the Docker run command, right? So here we'll be using the Docker run command. Docker run -t -p. Then you mention the port number. Then you can actually mention the image that you want to use, the image that you produced in the previous step. This is the container image that was produced. So basically, you just want to run your model, and preferably on Jenkins server. Right now, we are using Jenkins server, but it could actually be a different machine or any machine in the world that has Docker, right? Any machine in the world can now run your model, right? Because you containerized it. That's a big advantage of containers. Once you containerized it, anyone in the world can run your model anywhere. So you can run it in Google Cloud. Right now, my machine is sitting in Google Cloud. That's where I would run it. Yeah, I would run my application as a container, and 8880 is the default port. My model listens on, and I am exposing that to a host port, let's say 5000. And then probably I want to push the container image to the registry as well. Finally, if everything looks, maybe I want to test the code once, right? Test the, I want to evaluate, I haven't done that yet. So I have to produce some random square feet, and it should give me the correct price for that square feet. So test the model is something that I must do. And in order to test the model, I actually have already prepared another Python program, which I will quickly show you in the app folder itself. If you go to reuse model, there is not that one, test model API. So basically, once I executed the Python container, which is currently running on a Google Cloud machine. So in my particular case, the machine where I am running the container has this IP address, and it is export on this particular port. So this is the API URL. Once the model start running, you can access it through APIs, right? So it would provide an API interface, and you can send your square feet information to that API, and then it will give you a response, which is nothing but the price of those square feet. That's what this particular Python program is doing. So this program, anyone in the world can run it on their laptop, right? Basically, what this program, when somebody executes it on their laptop, what it does is it will speak to my Google Cloud machine, and the container that I'm going to run inside that machine, it will speak to that machine through APIs, and it will receive the data. The people can send the data, which is nothing but square feet data, to this URL, and my container would respond to them with the price, right? So this is a program that anyone in the world can run to get the price of a square feet that they give. So that's exactly what we are right, and that we are doing. So in order to test the model, yeah, we can run the testing from anywhere in the world, but we are going to run it from the same Jenkins server for now. And what we are going to do is we are going to simply execute this Python program. So if you are trying this out yourself on your own machine, replace this IP address with your IP. This is right now the IP address of the machine, the same machine where I'm running Jenkins also, because that's the machine I'm going to run the container as well. Anyway, so this is the program that you need to run to talk to the model and get it executed. So yeah, we will stop our pipeline here. So I already have a Jenkins job that I tried to set up, but I couldn't finish it because of some time taking stuff. And there is some minor fix that I still have to do on this Jenkins job, which I'm doing now. I hope you don't mind. Address already in use, it says. So there is some. I was working on a machine in the Google Cloud. What I did is I created a machine in the Google Cloud, and I was setting up Jenkins inside that machine. And it was that particular Jenkins server where I want to run these steps. I hope you understand what I mean. So I'm sorry, because of 2 hours, I'm not getting into individual small steps. But the idea is that you get a clear understanding on the pipeline, which I hope you did. So what I am going to do is now, yeah, something was running. Give me a second. Okay, I think I have my Python program already running on. I don't know which one is that. Okay, I think I think I have to change the port number. Uh, 5000 port is already in use by somebody else, so I'm actually going to change my port number to 5001. So in the test program, I should change it, and also the Docker run. When I execute the Docker run command, I want to use the port number 5001, not 5000. So this is some change what I'm going to make. And finally, I want to test the model. So what I do is, I think the same steps I have just written here for the clarity purpose for you guys. But what I have also done is I have already created a Jenkins job with all these steps one after other. The first step is now setting up DVC access and everything, and then downloading the file from the Google Cloud storage, then training the model, tracking the model, evaluating the model and everything, creating artifact, creating Docker image step. Then next thing is exposing the Docker container steps, and finally evaluating the model steps. Right, all these steps I have already wrote as a job, a single job in Jenkins. So if I quickly show you the job in Jenkins, this is it. Let me log into Jenkins. So once I log into Jenkins and I go to the job and I click on, yeah, every time I make a change in the GitHub, automatically Jenkins will start running. I'm going to cancel that one just to quickly show you the job configuration. So you can actually see I already configured this Jenkins job to automatically run every time there's a change in the GitHub. A developer change the data or change the code. I want Jenkins to automatically build a new model and do all this stuff, right? That's nice, right? Every time a developer, a model developer change something in the code, instantly he finds Jenkins taking his code, getting the data what was trained using for that particular code, and rebuild the artifacts, produce the container image, run it, check everything, probably push the container image to registry. That should be the last step, right? If everything works fine, you might want to push the container image to the registry. So for that, you can use a Docker push command, provided that you already have access to the container registry. So I have my own Docker ID called Basil Varghese, and then whatever linear, what was that? Linear or something, run ID. All right, so this would be the last step. So let's take a look at the Jenkins job. All the whatever I had told you just now, I have already written them in step by step in Jenkins. You can see that the first thing is about now setting up all the necessary libraries, the MLflow, all the Python libraries to be installed first. If you want to run the Python program, maybe I could have done it later also, at a later stage also. But yeah, I'm just preparing all the necessary environment in Jenkins as the first step to run my Python program. Then in the next step, as you can see, I'm actually setting up DVC, telling DVC where exactly the data is actually sitting. The actual data is sitting in this particular URL in the Google Cloud Storage. That's where the data is. And then in order to connect to that Google Cloud, these are the credentials it can use. So basically, I'm telling in the next step of Jenkins, I'm telling DVC, which is installed in Jenkins, that this is where you can take the data for training. And then if you scroll down further, next thing is to download the data from Google Cloud storage. Data snapshot is sitting in Google Cloud storage, get it downloaded. That's the next step. Then in the next step, I'm just trying to do the stuff, right? Training, executing the Python program, or you can say training the model, evaluating the model, and also finally producing an artifact. So all these things happen when I run this. And next, I'm going to mention, I should have added some comments so that you could have seen it better, but yeah, I was in hurry. So in the next step, I was building the model, into a Docker image. You can see the command used for that. And then after I built the image, I just wanted to execute my model, run the application as a container. For that, I use the Docker run command, and I want to use 5001 port because 5000 is already in use, and that's why. And once that part is completed, the next thing that what you want to do is you want to test the model, execute this test program, make sure that no, like I said, what this program does is it will speak to your model through API, send the square feet, and get a response, which is nothing but the price of that particular square feet, whatever you sent. So people from all over the world can use your model in this manner using API, which is too good, right? And then once, let's say you don't find any issues in the last step, probably it is time you want to push your container image to a registry. So that is the last step that you want to do. And there your Jenkins pipeline end. I'm going to click the save button. And what I have also done is I have configured this pipeline to run automatically every time a developer make a change, which is very good in a team environment, right? There would be 10 people developing the same model, making change in the data, making change in the code. So every time there is a update from them on the Git, Jenkins will start to build the container image, test it and push it to the registry. So as soon as the developer made the change, you got your container image available on the registry, unless there is no error that happened in any one of these steps. That's all. I'm going to let's, as soon as the developer push something to Git, the job will run automatically. I'm not waiting for that. I'm just clicking this button. Then the job would start automatically. You can see the 18th job had started. You can actually see how many failure happened before. I was kind of very close. So yeah, you can go ahead and take a look at the Jenkins output. You can see your steps are running fine. The machine learning and the necessary libraries are being installed and DVC being set up. DVC is downloading the stuff, which in fact successfully downloaded. And then it is then doing the other stuff like what is that? Yeah, whatever that is, they are all working. So it's now building the container image, which I believe I think it will take time. So once it build the container image, then it will go to the next step of um, running the container image, testing your application through API, and if that's also working, then push your container image to a registry. So these steps are now pending. Right now we are almost on the building step, and that is a time consuming step. We just have to wait until the container image is built. So in the meantime, I think it will take a couple of minutes. So if anyone has any questions, and I can ask now. And yeah, so another information what I want to share with you all. So we have I'm planning to start a batch on MLOps, which would be in about 2 weeks from now. That would be a more advanced project-based program where you would be working on more advanced project using MLflow. It uses MLflow, could be flow, then monitoring stuffs also, how to monitor your models, and right. So it's a 3.5 months long program that consists of two very advanced projects. So if you are looking out for a career switch to MLOps or want to learn MLOps for curiosity or for the purpose of job change, and those who are already coming from DevOps, I believe it's an easy switch, and it will be a perfect switch, less effort and perfect switch, because you already know DevOps. Most of the tool what we use in MLOps are repetitive tools, except few tools, I can say. Little things to learn, but not very complicated. So, but it would be a perfect switch, right? And this is the best time to do the switch for the next 5-10 years. I mean, it will be a wonderful time for you, right? If you are making the switch early. So yeah, basically, if you are interested, you can reach out to either me or Santosh. And yeah, I think that's a power problem. Yeah, Wi-Fi is not disconnected. Yeah, it's not. So yeah, that's what I wanted to convey, right? And in the meantime, it will take another couple of minutes, I guess. So anyone has any questions, you can ask me. Okay, let's wait for the container image to build. All right.
So Basil, where we define the Docker file for this?
We don't define the Docker file. What we did is we used a MLflow library to produce Docker image for us. And the same library can be used for producing the Docker file, and then we can use the Docker build command using the native way. That is also possible. So I will show you the command that was used. Okay, we got a failure actually. Is this the Jenkins? No, sorry. Yeah, no, I didn't get failure. So, in order to build the Docker image, we did not build it in the native Docker way. Instead, we used the MLflow command line for that. So this was the actual command we used, and this is the name of the Docker image that we are building using the command. But instead of doing this, if you prefer to use the Docker native way, because it's always good to keep a Docker file with us so that we have the control, we have more control. So in that situation, you can actually use the same command and use some flags to export it into a Docker file. Then you will get a Docker file in your local folder. Then you can use a Docker build command to build the container. That's also possible.
Okay.
Mm. Check if. All right. Yeah. Yeah, that's. I mean, I think because of the load, this may take a few more minutes. There is nothing we can do but wait, right? And yeah, yeah, I think I see some progress here. All right, and no, we actually plan to continuously take these sessions. So today you didn't get a opportunity to try things from your side. So maybe what we are thinking every 1 week that we haven't decided every week or every 2 weeks, we are planning to have a seminar like this, where I would be demonstrating different tools, technologies that are used for MLOps, so that you will actually get some hands-on sessions. It would be more like workshop sessions that you can try and practice all by yourself. So yeah, some sessions are being planned for that, and yeah, hopefully we will start from next week. I mean, this is the first day, and we will try to do this every week, once in every week. All right. So you can stay tuned through your, yeah, you can, anyway, we have your contact details, so you will receive an email or something every time a seminar is being planned. Okay. And you guys have any feedback that you want to share, like about the session or what you want to do next? You can share that also, either here or you can, if you can speak, you can send a chat message also. It's late. Or you can let us know later also if you have any particular suggestion on any topics. So there's a message from Alex. How will MLOps help DevOps engineers and monitoring team? MLOps is a different thing. Alex, did you mean to ask AI ops or there is something called AI ops that is all about bringing AI to our DevOps job, right? So that is kind of gaining momentum. Not good for us, but as a DevOps engineer, but there are tools available today. For example, you can tell instead of talking to Kubernetes API directly, you can speak to an AI to do the stuff for you, right? For example, deploy this application in this namespace. You can tell in human English language, and the AI tools can do the deployment on Kubernetes or right. So those kind of tools are kind of available today. A few of them are, many of them are already available actually. But again, I don't think they are ready yet. So AIOps is a different concept. It's not ML. I mean, AIOps does not mean managing the AI models. AIOps simply means using AI in your DevOps jobs. So MLOps is the actual things that manage AI models. Yeah, Alex, I hope that is the question you are asking. I mean, correct me if I am wrong.
Yeah, it's correct. So,
Yeah,
yeah, I thought MLOps will help DevOps and
yeah.
yes,
MLOps and DevOps are two different things. But
okay.
in many companies, especially in startups, DevOps people do MLOps jobs also. They don't have a separate team for machine learning. The same team do both jobs. So there are, right? It completely depends on the organization architecture. But yeah, if you think about it, a lot of the work are shared between DevOps and MLOps. So if you, right, it's kind of very easy for a DevOps engineer to do the MLOps operations. Yeah. Can I have recorded session of this? Actually, yes, I will be uploading these sessions into the YouTube channel that you can go through. Try to preferably practice also. I'll also be sharing along with the YouTube video. I would also be putting these links to the GitHub. Then also this documentation, what I have prepared just now. And yeah, you can try to practice yourself. Yeah, once it's available, we will be sharing you the link to the video recording. All right. Right. So where is our Jenkins job? Okay. Yeah, we got some failure at the end, which is not good. So while executing the test program, I got a failure actually. Actually, it's a connection refused, not a failure. It's a connection refused error. Is the connection refusal from the server? Yeah, I think I know the problem. I think I have not opened the port number in Google Cloud. So our container is actually running fine. Our model is actually running fine, and it is serving on the port number 5001. But I believe the Google Cloud don't allow the port number 5001. So I'm not planning to correct it now, because if I do, I have to rerun the job and it will take another 15-20 minutes. But yeah, the problem is that, I forgot to open the port number 5001 on the Google Cloud VM. That was the only issue. But yeah. Anyway, the same topics, we are thinking of splitting into small topics basically in the coming sessions. This would be the first one, and a lot of are yet to come. Weekly ones is what we are planning to schedule. All right, so stay tuned, and any questions? If you have any questions, I'll take that. Otherwise, we will wind up. And yes, the links would be shared to you through email once the video is uploaded on YouTube. Okay. If there is nothing else, we can wind up. Yeah, Alec. Right. So yeah. Thanks everyone for joining and staying. I know it's too late, but yeah, thanks for staying.
Thank you for the
And the
session.
next, try to wind up early. And yeah, thanks a lot, Akash, Alex, everyone. Yeah. Then see you in the next session. Bye bye.
Yeah, thank you. Bye bye.
Bye.